So some basics about the climate change, the climate system. So first things first is the difference between weather and climate. So they kind of hinted at this in the video, but you may hear people say things like, well, it's still super cold in Ottawa and we get tons of snow. So it's impossible that the Earth could be warming. First of all, we're talking about climate change, not necessarily global warming, although global warming is a thing. But the second thing is that your weather, like whether or not it snows tomorrow, that's weather, okay? And that's a short period of time. Climate is what happens in a region over a long period of time, okay? So rather than like, it's snowing in Ottawa today, that's weather, and the climate of North America over 100 years, that's climate, okay? So what are the trends over a long period of time? Okay, the sun's power and Earth's climate system. So almost all of the energy that is on Earth comes from the sun. We have not gone over the electromagnetic spectrum yet. That's next octomester. We'll be talking about, or you will be talking about optics, talking about the electromagnetic spectrum. You already know this though, right? So the electromagnetic spectrum is radiation. Basically all radiation that comes from the sun. Some of it you can see, that's visible light. And some of it you can't see. So you have ultraviolet radiation and you have infrared radiation. So the ultraviolet radiation is really what we're talking about here. It's invisible to the human eye, but it has a lot of energy, okay? And it comes from the sun. Radiation, so all radiation, including ultraviolet radiation, can be absorbed, transmitted, or reflected. Okay, and that's true of all radiation. But here it's particularly important when you're talking about climate change and the sun's radiation that hits the Earth. So certain things, so when the sun radiates radiation to the Earth, it will either be absorbed, transmitted, or reflected. Okay, so the surface of the Earth absorbs energy. So like actually, the lithosphere, the Earth, will absorb the energy. And it gains thermal energy from that absorption. It becomes hotter. That's what that means, okay? And the warm surface, okay, so if you think of like just, grass or desert or whatever, it gets warm and it emits infrared. So it kind of like sends it back out, okay? The energy that's absorbed by the Earth and the atmosphere is radiated by the Earth and the atmosphere. Okay, and you'll see what radiated means in a second. And when that happens, the energy is balanced between what comes in and what goes out. So here's an example. You have it in your notes. So this is a picture of the Earth's energy budget. So you see that the sun has incoming energy, okay? Some of that is reflected before it even gets to the Earth, okay? So the atmosphere reflects some of that energy, but a lot of it actually makes its way to the Earth. That is absorbed by the Earth, okay, and it heats it up. And it's then re-emitted or radiated back out, okay? So it's absorbed. It has kind of this sort of cycle effect, comes in, is absorbed, and then radiates back out. And when you have, so on the side here, it talks about like reflected. So that's the stuff that never even makes it to the Earth, okay? Absorbed, 70% of what comes from the sun is absorbed by the Earth, and that 70% is shot back out. Okay, not shot back out, but radiated back out, okay? So when we have this situation, the energy budget is balanced. So that just means that the energy we get from the sun goes back out, everything is equal. Okay, that's a good thing. All right, the components of a climate system. So these are things that you would have covered in grade 9, the different spheres of the Earth that interact with each other. So you have the atmosphere, the lithosphere, the hydrosphere, and the biosphere. Okay, those things all are part of the climate system. You talked about those in grade 9. So here you have just a picture of how all these things are interacting with one another. So remember, your atmosphere is the atmosphere. Pretty much everybody knows what that is, right? It's that air part that is above the Earth. You have your lithosphere, which is essentially the Earth's crust, the dirt on the Earth and the rocks. Then you have the hydrosphere. The hydrosphere is all of the water, including frozen water and clouds. And then the biosphere is everything that is living. Okay, and they all interact to in a whole bunch of different ways, right? So in grade 9, you talked about the carbon cycle, you talked about maybe the nitrogen cycle, and how these things all kind of factor in. Of particular interest to us is the carbon cycle, but the other cycles are also very important. All right, so this is the atmosphere. Okay, so again, this is review from grade 9. So your atmosphere has multiple layers. Not all of the sun's radiation gets through all of the layers of the atmosphere. The ozone layer, that's this layer in here. Okay, it absorbs a lot of UV radiation from the sun. Okay, that's why it's so important, is because it keeps a lot of that UV radiation from getting to us. And remember, UV is extremely high energy. That's also why it's really bad for your skin. Okay, but that's pretty much all you need to know about this. Living things. Okay, so again, talking about the carbon cycle in particular, right? So they change the gases in the atmosphere. They use up the gases in the atmosphere. They emit gases into the atmosphere. So photosynthesis brings in CO2 and releases oxygen. Cellular respiration, which is done by animals and plants, right? Photosynthesis is only done by plants. Cellular respiration is done by animals and plants, and animals breathe oxygen and emit CO2. Okay? And then you have sort of livestock, like cows and sheep, that produce methane gas during digestion. Okay? And that is also sent into the atmosphere.
I just missed the part of the blank from the...
Okay, so again, lithosphere is the kind of Earth's crust, rocks stuff. So it's going to absorb that radiation from the sun, and then it will emit this thermal energy, right? So, and there are different things, like we'll talk about heat sinks in a second. So, for example, you know that when you're on a beach in the summer and the sun is shining, I mean, there's UV rays, even if the sun is behind the clouds, which is why you still have to wear your sunscreen. But especially if it's sunny and you're on a beach, the sand becomes hot. And that's because it's absorbing that radiation and it's creating this sort of converting it to this thermal energy. Okay. Large bodies of water act as heat sinks. So a heat sink, and plants are also heat sinks, okay? They absorb energy and become warmer, but it holds on to that energy. So it doesn't actually radiate it like the lithosphere does. It just kind of grabs it and sort of holds it. So instead of increasing the overall temperature of the Earth with that radiation of the infrared, it controls it. Okay? And the ocean, for example, the oceans do that really effectively. However, water, and when in the video it was talking about the acidification of the oceans, and you may or may not have done the gizmo yesterday with the acidification of the oceans, but basically what happens is when CO2 reaches the oceans, it converts to an acid. So the oceans actually convert this, there's a process, a chemical process that happens. So that CO2 ends up becoming acidic, it becomes an acid in the oceans. And so the oceans absorb a ton of CO2. If you talk about this carbon cycle, it absorbs a ton. They absorb a ton of CO2. But the more they absorb, the more acidic they become. And the more acidic they become, the less they're able to absorb. Okay? So our oceans, thankfully, are still acting as heat sinks for us. And they will continue to act as heat sinks, but they're less and less efficient at that job. Okay? And then you have anything that's covered in ice surfaces, they're going to reflect that energy back out. Okay? That's why it's so sunny when it snows here. Right? When you have a big snowfall, it's just so blinding. That's why. Okay. Almost done. Okay, and then you have the albedo effect. So it measures how much of the sun's radiation is reflected by each surface. So here's just sort of different percentages for you. Okay. So as you can see, that fresh snow and kind of the glaciers, it reflects a ton of the sun's energy. And this is really important. So in climate science, we talk a lot about feedback loops and positive and negative feedback loops. And the more you go into biology, the more you'll hear this talk of positive and negative feedback loops. The idea behind a negative feedback loop, okay, is that, so if you look at the description that's on the slide here, it says we look at cause and effect in science. And in a positive feedback loop, the effect increases the cause. Okay, so B in the image, it says motivation increases success. Success increases your motivation, right? So if you're motivated to study for your test, you're going to study and have success. Then you say, hey, that worked. So I'm more motivated to keep studying, right? And so it kind of just gets higher and higher and higher every time. Whereas your negative feedback loop does the opposite. So it decreases the original cause. So here you have the example of predators and prey. So if you have a lot of prey, that will increase the number of predators, which decreases the number of prey, and so on. Okay? So this is an example of the water vapor feedback loop. So water vapor is a greenhouse gas. The warmer the temperature is, the more water is evaporated, and that enters the atmosphere, which makes the earth warmer. Okay? So the hotter the earth is, the more water vapor evaporates. The more water vapor that evaporates, it makes the earth warmer, which just makes it go and go and go and go and go. Okay, so that's a positive feedback loop related to climate change. Okay, the reverse is also true. So the cooler the temperature, the less water evaporates, the cooler the temperature gets, and so on. Okay, so this is the albedo feedback loop. If the earth temperature increases, more ice melts, like what they said in the video, right? So the earth temperature increases, the ice melts, that ice becomes water. Water absorbs energy and heat, increasing the overall temperature. Okay, so when you talk, like, I'm sure that you've heard about talk of like the ice melting, and the ice melting is an issue because one, it will cause the loss of coasts, and is already doing that. Okay, but two, it is a positive feedback loop. So the more ice that melts, the more water we have, the more heat is absorbed, the more ice is going to melt because it's warmer, and so on, and so on, and so on, and so on. Okay? That's it.